This is a early JK with an LS3 6L80. I can tell it's an early JK by looking at these sun visors. In 2010, they went to the extendable sun visors. In 2009, they went to the netting on that front console trim piece. So I'm guessing this is a 7 or 8. Either way, it's got an LS3 in it with a 6L80, and this is one of my favorite combinations. It makes the JK so much more enjoyable to drive, not only having the power on the road, but just the docile nature of the LS3. And I'm going to talk a little bit about the different options you guys have out there. This happens to be my favorite, and it has been for many years. When it comes to adding power to a JK, you got a lot of choices. Obviously, Jeep added the Pentastar, the 3.6 Pentastar in 2012, and bumped the horsepower up to about 280. It's a small displacement engine in a relatively heavy vehicle, so it needs to get up into its power band. It is dual overhead cam, 4-valve, all that, so it puts horsepower out, but not a whole lot of usable torque. So that motor is going to work hard to move your JK along, and it will do that. It will do that a lot better than the 3.8 did. You can add a supercharger to your V6, and that will obviously add power, but what you normally don't get out of a supercharger is drivability. We're talking about flat spots, hesitations, cruise control operation, and there's some that do it better than others. Chrysler operating systems in general are speed density, meaning they don't use a mass airflow sensor. They base most of their calculations off of intake manifold, vacuum manifold, absolute pressure, and then they use what's called calculated air. Most GM engines use a MAF, or a mass airflow sensor, and actual airflow calculations, so they can meter the air much more precisely, especially at altitude. We're probably at 4,000 or 5,000 feet right now, and we're going to descend down to 2,000 feet to Las Vegas, which is over there, in the same ignition cycle. So if you were to go, let's say, from 2,000 to 12,000 feet in Colorado, the mass airflow setup would have an advantage. In fact, in the old days, a lot of the fuel injection systems required you to stop about every 4,000 or 5,000 feet, turn the ignition off so they can get a barrel reading, and then start again, and that way you'd have a more accurate altitude compensation. But regardless, when you add a supercharger to a V6, you're basically adding a blower to a speed density operating system that is highly dependent on torque management. The Chrysler automatic transmissions in general are very torque management based, and so are the GMs. And they use information from the engine, like the map sensor, for shifting. So if you take a 1-bar operating system and you force induction it, you make it into a 2-bar operating system by not properly, there are proper 2 and 3-bar operating systems that manufacturers have available. In fact, I believe the Pentastar has a forced induction application on Maserati, an exotic version of it. But when you take a 1-bar operating system, throw a blower on it, and then fool things, the transmission's not going to get fooled. You can fudge it, you can make it better, but you're really never going to make it perfect. Manual transmission's a lot better. But then again, you're still going from normally aspirated to into boost, and you have to deal with those transitions, which you don't with a larger displacement engine. So we go to a larger displacement engine. Let's talk about the Hemi, which has been around almost since the JK has. I know back in 2008, 2009, I was starting to see Hemis in my shop, and I actually worked with AEV back then. And here in Las Vegas, we had some customers with Hemis that we had issues with, mostly with overheating. When it was 150 and 120 out, we were having overheating issues and modules going bad in the Hemis. In addition, with the Hemi, you do have other issues, the weight, the size, moving the steering shaft, in some cases hammering the firewall. I know that some manufacturers don't do that. I like moving the engine back. The new Pentastar JKs have opened the firewall up, so you don't really have to do that. turning the battery sideways with a Hemi to give the head more room. Although again, the Pentastar has kind of corrected that, so that's not required in the newer ones. Modifying the suspension for the additional weight. Now, what you did get with a Hemi was it is a Mopar Chrysler operating system, so it integrated relatively well into the network. Here's the problem. We're running a 3.8 or a 3.6 operating system. When that calibration was approved by the US EPA and Mode 6 data was installed, that's the monitoring data, it was installed for a V6, not a V8. Now we import and patch V8 parameters into that computer, and a lot of that Mode 6 data no longer applied. So there started to be some issues with emissions, and the US EPA does not allow hacked or patched calibrations. They have to be pure. So some of the Hemi guys had issues with compliance. I know it's getting a lot better, and I don't even know where they're at this point, but we've helped a lot of guys with getting their Hemis legal. So you have an engine that essentially is very large, and the JK has a small engine compartment. I work with a couple of engineers in Troy, Michigan. That's where some of the Jeep facilities are, and they could never put a Hemi into a JK for multiple reasons. One being safety. The Jeep JK has crumple zones, and with an engine that large, you would never pass the federal standards for firewall protection. So there's more issues than just engine performance. Now, is a Hemi a step up from the LS or the V6s? Well, if you're a Mopar guy, and I am a Mopar guy, I own a couple of classic Hemis, and I got a Challenger TA 6-pack and all that, but it just doesn't make sense to me. The JK's got a small engine compartment and requires basically a compact engine. So in our search for power, we have to look at what makes sense. So the Hemi will add power. I don't like the 5-speed Chrysler transmissions or the 4-speeds for that example. They're old technology. I don't even like the new 8-speeds. They tend to shift a lot. I think in the day, back in the 1920s and up, Dodge Brothers, Chrysler Engineering, they were on the forefront of technology. They really blazed a lot of trails, hydraulic systems like brakes and automatic transmissions, and they really were on the forefront, and they were on the forefront of American technology. Today, Chrysler is owned by the Italians, and is very much an international effort, collaboration to bring you what they offer. I feel personally, on the other hand, the LS is a better choice than the Hemi, and I have a lot of arguments. One being it's more compact, it's lighter. In fact, an all-aluminum LS3 like the one I'm in right now really doesn't weigh any more than a 3.8. The transmission's a little bit heavier. Overall, after the swap, you're going to pick up about 40 pounds, mostly down and low. Hemi's going to have that weight up and high, so you might notice it off camber. You're not going to notice that with the LS. Being compact, we don't modify anything in the engine compartment. I just had somebody ask that today. Yes, we do put the frame mounts on. We do not bash the firewall. We do not relocate the steering shaft. We do not modify the suspension. We do not turn the battery. It all stays stock. So this saves you some time. Now, the electronics are where it's at, and what we strived to do was keep these JKs compliant. That means you have to bring in the entire operating system and network from the donor vehicle. In our case, we have an engine control module, body control module, transmission control module, power mode module, and every one has its use on the bus. They communicate through something called a controller area network, or a CAN bus, and that's just a way of reducing wire count and trying to simplify something that's complex. But the reality is, when the manufacturers get these certified by the government, by the US EPA and the feds, they're in a configuration that the production vehicle must be produced to. You all know what's happening with Volkswagen right now, and it's mainly because they tampered with the certified configuration, not just in America, but over in Europe too. So this is really important to us. We want a pure network. We want everything to operate the way it's intended. We want all the redundancies, diagnostics, monitoring, and monitors are very important. Onboard diagnostics stands for onboard diagnostics, which means in the old days we had offboard diagnostics. OBD1 had certain requirements. You only had to throw certain trouble codes. OBD2 in 1996 required that not only you throw trouble codes but store them and store information that can help a technician, like freeze frame data. Has onboard monitors to monitor different subsystems like oxygen sensors and catalytic converters and you name it. It's pretty much monitored, and that way when you go in for an emissions test, whether you do a 3-gas test, HCCO, NOx, a 2-gas test, HCCO, NOx usually needs to be tested with a dyno. I guess you could call that IM240. HCMCO can do a 2-speed tailpipe test. Tampering means have you changed anything or removed any of the emissions components. And I've been an emissions inspector a long time, and I've pretty much seen it all. Then you have the software, and the software really is where it's at. Software is what tells everything what to do. It diagnoses as you drive. It keeps you safe with reduced power modes. It monitors, and take for example a brake pedal switch. You think that's such a simple thing, but they're actually redundant brake pedal switch signals, and they're synchronized, and they're received by independent modules so that they can be cross-checked. And today, brake pedal sensors are not just used for turning off cruise control or turning on your brake lights. They're actually used in engine performance. The network is monitoring the position of the brake pedal, not only to turn your lights on, but if it knows you're going down a hill and you're riding your brakes, it'll bring some compression braking in. So it has function beyond what it did 20 years ago. This is why it's so important we keep the network in a state that it was certified, because there's things we don't even know when it comes to the onboard diagnostics and the monitoring data. And I'm going to go ahead and throw myself into 2-wheel drive. We don't need 4-wheel drive anymore. There we go. So there's a lot of functions that we don't even understand. There's unbelievable amount of code in these systems, and these modules communicate with each other. So our goal was to bring all that into your vehicle. That way you're being monitored exactly the way GM intended it. You're safe exactly the way GM and the government demands it. So there is reduced power modes. We don't try to take a shortcut and go around these systems that are designed to make you safe and compliant. Emissions are becoming more and more important, and things like power down modes, when you turn your key off, a lot of things happen. There's adaptives being stored, learned adaptives in the transmission, in the engine, in spark curves, fuel curves, even the body control module. So those things need to be powered up and down properly. We're not running an over-the-counter GM performance controller that is essentially a glorified hot rod. We're running a complete US EPA approved production calibration. So the only way to achieve that was literally to do it the hard way. Bring everything over. Bring every module over. Bring all the wires over. And in the early days, it wasn't easy. It was a lot more difficult than a Hemi. The hardware was easy, the install was easy, but the electronics were not. It was complex. But in the last 8 years, we have simplified this process down to, I want to say we've rationalized this process. We've got it down to almost the minimal amount of install labor required. Now we are down to about 6 wires that you must install into the vehicle, and I think we're going to get that down to plug and play once we source a couple of connectors or make them. But when you compare it to a Hemi or a Supercharger or a turbocharger, what you are doing is you are literally installing a complete entire network. You have a Jeep body on top of a Silverado chassis or a Camaro chassis. It's serviceable by your dealer. You can have it inspected for emissions in California. It has all the onboard diagnostics that are required, that if you ever have a breakdown or a problem, it can go to your dealership. The wire colors, we run factory wiring harness, power distribution, ground distribution. The communication between all the modules is all factory. All the factory scanners work, bidirectional controls. It's all there. So essentially what you have is a pure operating system that can be diagnosed and repaired by any GM facility. You're not running a supercharger where you have a hack calibration. You're not running a Hemi where you've imported it into a 3.6 or a 3.8 calibration. You're running a pure calibration, and I feel when done properly, it's the only way to do it. This LS3 I'm driving right now is as docile as you can imagine. It feels like I'm driving a 3.8. I can't even hear the motor. All I can hear is a stupid light bar and some wind noise and tire noise. Idles at 550, 600 RPM. Still has close to 450 horsepower. You'll never be caught going up a long grade below the speed limit. In fact, you could cruise this Jeep at 90 if you want. This is a heavy four-door JK. And you have all the onboard monitoring to keep you safe. So this is not a hot rod install. This is an OE install, I guess I could say. Everything that is required to be there is there, and the end result is it runs as the manufacturer intended it, and it keeps you safe the way the feds require it. So we chose to go that route. We chose to go the hard route because it's the right way to do it. Now, if you look at the other ways guys are doing this by throwing an LS into a Chrysler operating system or eliminating critical modules, yeah, I mean, you could get away with that, and I guess depending on your intended purpose, that may work for you. But we chose to make it as honest as we could, and there's just no shortcut to that. So I have vehicles all around the world right now, and guys are encountering reduced power modes. Guys are having brake switches go bad and having their engines go into reduced power, but that's the way it was intended. And I can tell you, after the last 8 years and a couple of hundred swaps, I believe this is swap 204. We've had some failures. You know, we've like everybody else, we've had small issues here and there, but we've never had anything that the original operating system didn't catch and stop. So we're proud of that. And again, there's things going on in these operating systems we don't understand. I don't understand, and I've been studying these things my whole life. There's things engineers build into these that they would understand and we wouldn't. So why second guess the guys that designed this? Put it in the way it was intended. Let it run the way it was intended. Let it monitor itself, power down, power up, have redundancies the way it was designed. And in the end, you're not only safer, but you end up with something that just will run for years. And I have customers that have over 100,000 miles on their LS swaps, and some in the harshest environments. And the only way you're going to get that longevity and drivability and reliability is to do it the way it's intended. And just driving this LS3 now feels so right to me. You can see the RPMs are low, dead smooth with the hydraulic motor mounts. If I got to get on the highway and get up to speed, there's no issues with that. I'm not going to worry about getting on the on-ramp like I used to with 3.8s. You want to cruise 1,000 miles in a day at 80 miles an hour where it's legal, you can do it with no issues. The Hemi will do it too. I've driven a lot of Hemis. Hemi's kind of a pumped up engine. After about 500 miles, well, not even that, maybe 300 miles, it starts wearing you out. Where the LS is so quiet and smooth, it's like being in your living room. And it is a different style of driving. And I put my family in mind, and we drive to California. We've been in New York and Florida from Las Vegas, and they love it. It's just like a mobile room. There is no engine screaming, trying to go up a hill. There is no rumble. that's loud every time it downshifts. It's just the way it's supposed to be. It's like driving a Denali. And then to know that everything has been brought over for safety and reliability, and of course performance. Don't forget, we want it to perform well, but we also want everything else to be in place to make sure it's safe and protected. These LSs have hot protection modes, oil protection modes, all sorts of modes that are designed to protect it and you. If you bypass critical components and software, those modes are no longer there, and there's a chance you're not going to go 200, 300,000 miles with an engine. So that's why we do it the way we do it. Those are the options that are out there now. There will be some more options soon. I do believe Jeep's coming out with a 4-cylinder turbo, which I'm not really sure is going to be a big hit in a heavy JK off-road. They're coming out with a diesel finally in North America, I believe. At least that's what I've been told. It's going to be a 3.0 liter VM Matroni. Actually, it's a pretty good motor. We'll see what the specs are on it. We're going to be doing our own diesel swap with a 2.8 GM Duramax. I believe the Duramax is going to get excellent mileage and good performance. If you compare the Duramax to the baby Duramax to, let's say, a 4BT, horsepower, they're very similar. Torque-wise, the 4BT has a lot more torque, but the Duramax still has over 300 foot-pounds of torque, and it's a small, lightweight, modern aluminum engine. So I think it makes sense. It's US EPA compliant. We're going to be doing one. We're now working on the Gen 5 engines. We've got a few of them going, and they're holding a lot of promise with the direct injection, variable valve timing, continuous variable valve timing. And are they revolutionary enough to not get an LS3? No. The LS3 is just such a good motor. It's at the pinnacle of the internal combustion Gen 4 technology. So it holds its own with the Gen 5s. Under a light load, the Gen 5s are more efficient. But as far as power goes and just overall drivability, the LS3 is excellent. There's no AFM in an LS3. There isn't an L99, which is the automatic version. There's no VVT. So it's about as simple of a motor as you can get. It's extremely docile, but still has a tremendous amount of power. I've had LS3s go through pretty much every trail you can imagine. The Rubicon, Fordyce, King of the Hammers. I'll be posting some videos of Baja soon. Outback in Australia. Pretty much anywhere. So there you go. I just killed a bunch of time on another test drive, and I hope you learned a little bit. Thanks.